Every world believes it will last forever. The Sunstone way was wrong. In the early 13th century, an Icelander named Ráðólfur wrote a story that has puzzled scholars for 800 years. A king stood aboard a ship in thick snowfall. He called for a stone. When he held it up, light streamed from within the mineral, and there beyond the gray, the hidden sun revealed itself. This was the Sólarsteinninn, the Sunstone. For centuries, historians dismissed it as allegory, a pious metaphor for faith-piercing darkness. But the Norse were among history's most daring navigators. Between the 8th and 11th centuries, they crossed the North Atlantic without magnetic compasses, an instrument that would not reach Scandinavia until the 16th century. They read the sea by the shape of swells, by the color of the water over shallows, by the flight paths of seabirds returning to land at dusk. Experienced navigators could detect the smell of grass carried on offshore winds from 100 kilometers away. But when clouds swallowed the sun and stars both, and in the North Atlantic that can last for days, they needed something else. Something that could see through the gray. The mineral the sagas describe is Iceland spar, a clear form of calcite with a remarkable physical property, birefringence. When light enters a piece of Iceland spar, it splits into two separate rays, each polarized at right angles to the other. Look through it, and everything appears double. Rotate the crystal, and one image brightens while the other dims. The angle of rotation that produces equal brightness reveals the polarization angle of the light entering the crystal. Sunlight scatters through the Earth's atmosphere in a predictable pattern. The sky is not uniformly lit. Its light is polarized in concentric rings centered on the sun. Even under heavy cloud cover, enough polarized light penetrates for a trained observer to locate the sun to within a few degrees. The Iceland spar is a decoder. By finding the rotation where both images match, a navigator can read the sky's hidden polarization map, and from that map, derive the sun's position. The mathematics behind this is elegant, but the practical skill it demands is considerable. Modern experiments have shown that calibration takes practice. A novice with a sunstone can find the sun to within about 7 degrees. An experienced user, within 3. On a voyage across the open Atlantic, that margin of error was enough to keep a ship on course toward Greenland's ice blink horizon. No other culture in the world is known to have developed this technique. In 1967, the Danish archaeologist Thorkild Ramskou proposed that the Solstenen was a real navigational tool, the first modern scholar to take the sagas literally beneath the metaphor. His paper, published in the Danish journal Skalk, was met with deep skepticism. The medieval text could be allegory, critics argued. The word Solstenen might simply mean a mineral that glittered. No physical example had ever been found. The theory might never leave the realm of speculation. Then, in 2002, divers working off the coast of Alderney in the Channel Islands made an unexpected discovery. They were excavating the wreck of an Elizabethan warship, the Alderney, which sank in 1592, when they found a small, water-worn crystal lodged in the ship's frame. It was a piece of Iceland spar, roughly cut to the size of a matchbox. It had been carried aboard a ship that sailed a century after the Viking Age ended, a relic preserved from a tradition already lost. The Alderney crystal did not prove the sunstone theory on its own. A captain might have kept it as a curiosity or a talisman, but it placed the mineral in the hands of a seafarer, at sea, in an era when magnetic compasses were standard. Why carry a polarizing crystal unless you knew what it did? Experiments that followed were more decisive. In 2011, a team from Eötvös Loránd University in Budapest sailed the Arctic aboard a research vessel, carrying a piece of calcite identical to the Alderney crystal. They navigated entirely by the sunstone method. On overcast days, when the sky was a featureless sheet of white, their error in sun position averaged 1 degree after an hour's sailing, an accuracy the Vikings would have found entirely adequate for crossing the Denmark Strait. Yet no manual survives, no carved instruction. No Norse text explaining how to read the polarization pattern. The knowledge was oral, passed from helmsman to apprentice, generation after generation. And the conversion of Scandinavia to Christianity, with its new institutions and new ways of knowing, let that knowledge dissolve. By the time the magnetic compass reached Iceland, the sunstone had been reduced to a line in a church inventory. One Sólarsteinninn, made of crystal, property of the cathedral at Hólar. A navigational instrument shelved in a reliquary, its purpose already half forgotten. The sunstone did not vanish because it stopped working. It vanished because a culture that carried knowledge and living memory was replaced by one that wrote things down, and no one had thought to write down how to find the sun through clouds. A technology that guided ships to Greenland, to Vinland, to the edge of the known world, slipped from human understanding as quietly as the crystal itself, lying in the dark of a shipwreck for 400 years, waiting to be rediscovered. Another world remembered. Walk the next one with me.